Hey guys, welcome to Safi Mixed. In this video, I will let you know that the angle subtended at the circumference of a circle by a chord in a given segment are always equal. This is a theorem that is we want to prove that the angle theta 1 equals theta 2. So to this end, uh, I remove this figure and I begin right from the beginning. I consider a circle with center O and I take 2 points on the circumference, point A and point B, and I connect point A to O and point B to O. Then the angle subtended at O I denote with alpha, and I join A and B to construct a chord AB. Now this chord divides the whole circle into two segments, one the major segment at this side and the other minor segment at this side. Now I construct two triangles. The first one, I take a point C at this position and I join point C to A first and then point C to B. And the angle at point C I denote with theta 1. So I have a triangle ACP with angle at vertex C equals theta 1. And this angle lies in the major segment of chord AB. I construct another triangle by first taking a point D at the circle, join D to point A, and then D to point B, and denote the angle subtended at point D with theta 2. Now, theta 1 and theta 2 both lie in the major segment of chord AB. With this geometry, now I use a theorem that I have already provided a proof. And if you don't know, you can click on the link in the description to watch that video. And that goes like the statement of that theorem goes like this: the angle subtended by an arc at the center of a circle, that is this one angle, equals twice of the angle subtended by the same arc at the circumference of the circle. If I consider the arc AB, it subtends an angle alpha at the center and angle theta at the circumference. According to this theorem, theta 1 is linked to alpha, and from these two triangles, that is triangle ACB, ACB, and triangle AOB, this one triangle AOB, according to this statement, I can write that the angle alpha equals twice of theta 1. Again, if I now consider triangle ADB with reference to triangle AOB, again, I have the same statement because theta 2 is an angle subtended by the arc AB in the major segment, and I can link theta 2 to alpha by the same relation. That is from triangle ADB and triangle AOB, I can write that alpha equals 2 theta 2. So I write these two relation 1 and 2 is in the light of this theorem. Since the left side of each equation equals alpha, therefore I can compare equation 1 and 2 to write 2 theta 1 is equal to 2 theta 2. I can drop 2 on both sides and can write the relation as theta 1 equals theta 2. And this is another theorem. We call this Chord's theorem 2. And we state that the angle subtended in a given segment by a chord are always equal. So theta 1 is one angle, theta 2 is another angle. These two angles are subtended by the same chord, and both angles lie in the same segment, that is the major segment in this case. So according to this relation, we can say that the angles subtended in the same segment by a chord or by an arc are always equal. Thanks for watching.